Welcome to the deep dive. Today, we're getting to something absolutely critical, something that affects, well, every single meal you eat. We're talking about securing the global food supply.
It's a massive challenge.
Huge! I mean, look at the numbers. Pests and diseases, they wipe out up to 40% of global crops every single year.
40%. That's just enormous.
Right. And the cost, it's like this unseen tax on the global economy, over $290 billion a year. Let's unpack that.
Okay. And that's really the mission for our deep dive today. We want to explore why our main response for decades, chemical pesticides, is, well, fundamentally flawed. You could call it a Pyrrhic victory.
A Pyrrhic victory, meaning the cost of winning is too high.
Exactly. You get diminishing returns and these massive hidden costs, these unpriced liabilities. And we want to show how nature's own solution, vital control, is actually proven economically better and really scalable.
Okay, let's start with that flaw in the chemical approach. You mentioned diminishing returns. That sounds like test resistance, right?
Precisely. It traps farming in what people call the chemical treadmill. You spray, the few resistant pests survive and breed, so then you need more chemicals or newer, maybe harsher ones.
And it just keeps escalating. I saw this stat that really brought it home for me, the arthropod pesticide resistance database. It tracks 632 species that have developed resistance.
632. That treadmill analogy is spot on, isn't it? It shows the strategy is just fundamentally breaking down.
But it's not just about effectiveness, is it? There are other costs. You mentioned unpriced liability.
Oh, absolutely. The hidden costs are, frankly, terrifying. We're not just talking dollars and cents lost on the farm. We have huge human health costs tied to things like endocrine-disrupting chemicals, EDCs, used in many pesticides.
DDCs, those are the ones that mess with hormones.
That's right. They interfere with our body's natural hormone systems. And the estimated cost. In the U.S. alone, it's around $340 billion every year.
340 billion from EDCs and pesticides.
Huge chunk of that, yeah. And a major, really worrying part of that cost is IQ points lost in children due to prenatal exposure. So, the question becomes, can we actually afford not to change course?
It really puts it in perspective. The costs seem undeniable. So if the chemicals are so problematic, why isn't biocontrol everywhere already? What exactly is this strategic alternative?
Right. So biocontrol is basically using nature's own tools. Think of it as pest management based on ecology. It works mainly through three kinds of strategies.
Okay, what are they?
First, you got predation, simple concept. Introduce predators that eat the pests. Think lady beetles gobbling up aphids.
Classic example. What else?
Then there's parasitism. This often involves parasitoid wasps, tiny insects, usually very specific to one pest laying their eggs inside that pest. Grim for the pest, great for the crop.
Highly targeted. And the third?
The third is pathogenesis. This means using naturally occurring microbes like bacteria, fungi, viruses that make the pests sick.
Make them sick. Can you give an example of that?
Sure, the most famous one is probably Bacillus thuringiensis, or BT. It's a type of soil bacteria. Specific insects eat it, it produces a toxin in their gut, and essentially it kills them. But it's harmless to us, to wildlife, to beneficial insects.
Okay, so predation, parasitism, pathogenesis. Got it. You mentioned earlier that biocontrol is economically superior. How does that work?
This is the really fundamental economic shift. Biological control agents, when they establish, they're essentially appreciating assets.
Appreciating, meaning they gain value.
Yes, they reproduce, they spread, they keep controlling pests year after year, often with no extra cost to the farmer once they're established. It's like investing in a self-replicating workforce.
Okay, I see. And chemicals.
Chemicals are the opposite. They're depreciating assets. Every time you spray, you're killing susceptible pests, sure, but you're selecting for resistant ones. You're actually reducing the future effectiveness of that chemical. The value goes down with use.
That's a powerful way to frame it. Appreciating versus depreciating. The theory sounds great, but does it work in the real world? Do we have solid proof?
Absolutely irrefutable proof. We can look at a couple of landmark cases. Let's start with a huge success story from Africa, tackling the cassava mealybug back in the 70s and 80s.
Cassava, that's a vital food crop for millions, right?
Absolutely critical. And this mealybug was devastating it. The solution? A modest investment, about $47 million, to find and introduce a specific natural enemy, a tiny parasitoid wasp called Anagerus lopezi.
Just $47 million. What was the return?
The economic benefits were estimated somewhere between $9.4 billion and $20.2 billion. The benefit cost ratio, somewhere between 200 to 1 and maybe even 740 to 1.
Wow. That's incredible. And it secured foods for how many people?
Over 200 million people rely on cassava in that region. So yeah, a tiny wasp, a relatively small investment, and a massive continent-wide impact.
Okay, that's a historical example. What about something more recent? Does it work against modern invasive pests?
Great question. Let's look at California right now and its fight against the Asian citrus psyllid. This insect spreads a disease that's devastating citrus trees. It wiped out much of Florida's industry.
Right, Huanglongbing or citrus greening disease, a nightmare for growers.
Exactly. But in California, they've deployed another specific parasitoid wasp, Tamarisia radiata. And the results. Since 2023, they've seen a reduction in psyllid densities of over 70% in areas where the wasp established well.
70% reduction. So Biocontrol is actively protecting California's, what is it, a $7.6 billion citrus industry?
It's a key part of the defense strategy, absolutely. It shows this isn't just historical success, it's a vital tool today.
Okay, the proof seems solid, but scaling this up, hasn't that always been the challenge? Rearing enough ladybugs or wasps?
It was a major barrier. But technology is really changing the game now. We're seeing huge advances in mass rearing techniques, automation, using artificial diets instead of live hosts for some species. It's becoming much more efficient.
And getting them out into the field, you can't just sprinkle them by hand over thousands of acres.
Right. And that's where precision delivery comes in. Think drone systems. There are specialized drones now that can release beneficial insects evenly across, say, up to 15 acres in just one flight. Much faster, much more precise.
Drones deploying wasps? The future is here? And is the market ready for this? Are farmers and consumers demanding it?
Definitely market pull. We know consumer interest in sustainability is sky high. One figure I saw was 92% of consumers are interested. That creates a real financial incentive for growers to adopt safer, more sustainable methods like biocontrol.
So it's not just an environmental choice, it's a business decision too.
Increasingly, yes. And it fits perfectly into broader sustainable frameworks that growers are adopting, like integrated pest management IPM or regenerative agriculture. Biocontrol is really a cornerstone of building resilient farming systems. It's about managing the whole ecosystem.
Which makes sense. So wrapping this up, the takeaway seems clear. The future isn't just about finding the next chemical kill switch. It's about smarter, data-driven systems built on biological, ecological principles.
Exactly. Managing an ecosystem, not just battling a single pest in isolation. But there's a catch.
Ooh.
Yeah, here's something for you, the listener, to think about. We have all this evidence, better economics, better safety, proven effectiveness, yet getting new biological products approved through the regulatory hoops, it's often incredibly slow.
Slower than for chemicals.
Sometimes, yes, especially in some regions. For example, getting a new biological control agent approved takes, on average, 1.6 years longer in the European Union than it does in the United States. Think about that delay.
Wow. So the science is moving fast, the need is urgent, but the regulations are lagging.
That's the challenge. We need policymakers to recognize the urgency and the evidence and create dedicated, faster approval pathways for these safer, proven biological solutions. Otherwise, regulation itself becomes a bottleneck, stifling the very tools we need to secure our food supply sustainably. The policy really needs